Welcome, everyone. Understanding media flows in Microsoft Teams and Skype for Business. So today, we're going to talk about media flows. And I've done this talk in the past for Skype for Business a couple of times. Just out of curiosity, who has seen this session or similar session for Skype for Business before? Okay, that's a lot. Who is here to learn specifically or has only interest in Teams and has no prior experience in Skype for Business? Okay, perfect. Very interesting. So, today, we are going to talk about media flows. We want to understand why is there a challenge? Why are media flows complicated? Isn't it just like I send traffic somewhere and everything works? How does it work? What is the problem? And what solution do we have? So what does Teams and Skype for Business do to make the media path as optimal as possible? Then we're going to look at logs to see all of that in action. And then we'll discuss call flows, different scenarios. How does the traffic flow in certain conditions? And finally, we are going to look at tools and how they can help us with troubleshooting. So we really want to understand these media paths. We want to understand how an endpoint that wants to establish a media path, how it can find this optimal media path, and how it can identify connectivity issues. The key learnings, hopefully after the session, you go out of the session and say, oh yeah, I understand now a couple of things. I understand the traffic between clients can go peer-to-peer, but it doesn't always do that. I will understand why it's great to have a local internet breakout for my different offices and not get all the traffic first to a central location where I might want, with an MPLS, where I then might want to break out into the internet. And then I just want to stress the UDP ports, 3478, 3479, 80, and 81, they are super important, and you need to open them for optimal user experience. Before we jump into the topic, I'd like to introduce myself. My name is Thomas Binder. Based on the hands that I've just seen who have seen sessions before, well, seems a couple of you know me already. I've been for 10 years in Microsoft. I'm part of the Skype for Business product group. My role currently is to work on IT Pro readiness, so whenever we ship new features in Skype for Business, I want to get sure that we have material out there so that IT pros understand what are these features. Well, first, they are aware that these features are shipped. What are these features? How can they configure it? How does this impact their environment? How can they manage it? I do that for Skype for Business, and I will also do that for any cloud voice-related features in Teams. You can find here my email address and zip address. If you have any questions, if you want to discuss any of these topics, feel free to reach out to me, and then I'm always happy to engage in a conversation. I'm based in Austria and Vienna, and this is my daughter. She's 3 years old at the moment, and the joy of my life. Important is what we're going to cover in this session and what we're not going to cover. So we will just talk about the media scenarios. So we will not talk about how signaling works or sign-in or all that kind of stuff. We might touch in 1 or 2 moments on these, but it's really about the media. Second, we talk about connectivity and quality. So after the session today, hopefully you will understand how the clients can connect to each other, can connect to Office 365, but it's really just like, can they connect? You can do a lot of bad things to your traffic, where you have connections, but then still bad quality. And there are other sessions to talk about that. This is basically the first step, get sure that you can connect. Then later on you can do the second step, get sure that the connection has good quality. We will talk about Skype for Business Online and Microsoft Teams. However, for the logs, for the most part, we will be looking at the Skype for Business logs. And once I show you the Teams logs, you will understand why. A couple of terms that I'm going to use a lot in this session. The first one is the candidate. The candidate is the concept. It's a combination of an IP address and a port that I'm going potentially to use for a connection. So I want to call someone, so I need to allocate a candidate on my PC, that's my local IP address, and a port so that the other peer can potentially connect to that. Then there's ICE. ICE is the Interactive Connectivity Establishment. It's a protocol. That's all the logic. So everything we're going to talk here about is basically the ICE protocol. ICE protocol uses 2 different techniques. First one is STUN, Session Traversal Utilities for NET. So that helps us somehow that we can traverse a NET device. Sounds exciting? We will hear what it exactly does. And then there's the turn. The turn is a traversal using relay net. Oh, great, there is a relay. That sounds good. And in terms of relays, I will speak a lot about relays. There are two types of relays that I will be speaking about, and I will be explaining what these relays are. The one is the media relay, and the other is the transport relay. So let's talk about the challenge. What are we here? What are we trying to solve? So I have two users. They are Alice and Bob. And this is, at the moment, not even specific to Skype for Business or Teams. It's just really, imagine you have two endpoints and they want to establish communication to each other. So first of all, we need to have some signaling where they can tell, hey, I'm online, and hey, I'm available, I want to talk to you, this kind of signaling information. So they need to send this signaling somewhere, and for that we have Office 365. There's a service, they sign in, and they can now exchange presence information, can send instant messages, and can let each other know that they want to establish a call. A call that could be audio, that could be video, that could be desktop sharing. And if they decide that they want to do a call, well, then we would like to send the media as direct as possible. Obviously, we could send everything to Office 365 to the cloud and relay it there, but we don't always want to do that. And the easiest example is you have an office. There are two people, they want to establish a call to each other. Maybe they are on different floors and different parts of the building, and the whole network is routable. So they can send the media directly. Why would you want to send that to the internet and introduce additional delay, put additional load on the network to the internet? Just keep it local. So we want to do that. However, often this is not possible. So these users could be sitting at home, sitting in a hotel, at Starbucks, at a customer, and there might be net devices or firewalls that don't allow them to have this direct connection. That's a problem. Then there's Charlie. Charlie might be sitting inside your corporate network. Alice might be sitting outside. Signaling, exactly the same. You would configure your firewall that the signaling can go to these known IP addresses, FQDNs, to the cloud. But then when they want to establish media, most likely your firewall will not allow that. And it shouldn't, because this media could be at any ports, and you don't want any random client on the internet to send traffic directly to your internal network. So we need to solve for that as well. And then there's Dan. Dan, signaling the same. They are both in the internal network, and as just said, well, let's keep the traffic local if possible. But now we need to have some logic. Well, first of all, there are a lot of calls that won't happen at all. And now we need some logic that helps us to establish these different call flows. So let's break the problems down. The first one is the NAT. NAT is network address translation, and it's a fantastic thing because you're sitting at home, your internet service provider gives you one IP address, you have your router, and it functions as this network address translation device, and now you can have all your 25 Xboxes, PlayStations, iPhones, PC, all of them get internal IP addresses, and they get translated with the NAT to one external IP address. And that's fantastic because now you can have so many IP addresses, and it's also great because it provides you some security. If someone on the internet just wants to send you randomly traffic to one of your internal machines, well, the net wouldn't know where that should go, because this traffic would go to your public IP address, and then the net would say, okay, great, I didn't ask for this traffic. Where do you want? I don't know where to send it, let's just drop this packet. So there is security coming from that. However, there's also this disadvantage of, well, maybe I want the traffic to come in. So how do I tell my net first that this traffic should be really coming, or maybe how can I establish this traffic first, or send out the packet first, so that the net knows, oh yeah, this is actually this device trying to establish a connectivity, so I look at any traffic coming back, I should let that back in. And then obviously there are the corporate firewalls. The goals are similar, it's just much, much stronger security. Also, internally we are doing sharing of IP addresses. So there are fewer public IP addresses that you have than you have internally. You want to control the traffic that is coming. You just don't want to allow random traffic. And there might be additional features like deep packet inspection proxies, and all of that you really don't want, will prevent that, that these two users have a connection directly to each other. Another challenge might be HTTP proxy servers. So usually they use that they proxy the traffic coming from your internal network to the internet, and they will give you security because they will scan traffic, they will allow certain traffic and deny other traffic. However, for Skype for Business and Teams, well, for real-time communication in general, this is really bad. Because they don't allow UDP traffic, it's based on HTTP, so they will only allow TCP traffic, and we'll talk a little bit later about why UDP traffic is really preferred for real-time communication. So the challenge here is that they might corrupt packets or might block some traffic, or that they might just slow down what is happening. And every time we talk about real-time communication, well, it's called real-time for a reason. You want it to be as quickly as possible from one point to the other, so you really don't want to introduce any latency. The solution is called ICE Stun and Turn. So we talked about ICE. I introduced it. It's the interactive connectivity establishment. So you can see here in the middle there's the client, and there's traffic coming from somewhere, from the internet, and it's blocked by either a net or a firewall. For the signaling, we have already established that there is somewhere in the cloud this service where we can do signaling to. By the way, Skype for Business uses SIP for signaling. We don't use SIP in Teams. In Teams, all of that is HTTPS, it's REST API. We use also WebSockets for more persistent communication, so no more SIP. But what we use in terms of ICE is very similar. We also introduced this Stun and Turn server. So these are servers that function as a relay, can function as a relay for us. So if the client wants to talk to someone but can't because there is no direct connection, then we can always use this Stun or Turn server as a relay. At the same time, this relay helps me to discover my public IP address and will allow the net to accept incoming traffic. And the way it works is my client sends a packet to this Stun Turn server, to the relay. The server gets that message. It will then allocate candidates for me, and we'll talk about that in a little bit more detail. It will send back a packet to me, and then I know, oh, my public IP address is actually this, and now my internal client, my PC at home within the internal network, knows what the public IP address is of the net device. And maybe I can accept traffic there. And ICE is now this overarching process that includes all these phases of the connectivity establishment. Which components use ICE? Well, basically every endpoint that does media. So these are all my clients, my mobile client, my PC client, and all the service components that I'm using. So if I'm having a conference, when my clients talk to the conference service uses ICE to establish this media path, or we use that together. If I'm doing a call to the PSTN via Office 365, same thing is going to happen. It's going to use ICE. And we use that for all real-time modalities. So for audio, for video, for desktop sharing. In Skype for Business, that's also true for one-to-one transfer. In Skype for Business, if one user sends another user a file, this is sent in real-time protocol over the same mechanism as we would send audio or video. In Teams, we know we don't do this. In Teams, we upload that to to OneDrive for Business, and then the other user can download it from there. And then there's this relay component that I just spoke about. The relay component provides Stun and Turn, but it doesn't terminate any media. So technically, it's not an ICE endpoint. But it's very important in my ICE negotiation. So now there exist two types of relays. There's the media relay, and there's the transport relay. And the media relay is that component that we built for Skype for Business server and the versions before that. This version that you would, the edge server that you would install on-prem, it runs the media relay. And at some point we decided, well, that's really great technology that we have here. We should have it as a cloud service. So we just took our on-prem servers and put it in the cloud and run it there for you. And then over time we realized this is not really built for the cloud. This is built for on-prem. So we need to build a cloud solution. So we built this transport relay, which is a cloud-born service and has much more inbuilt this scalability that we need, the management ability. But also it helps us to give us more flexibility when you need to use one of these transport relays. The media relay is static in one data center. So if I'm a user and my servers or my service is homed in Dublin in Ireland, every time I need to use a media relay, I will go to Dublin to Ireland. So I'm homed based in Austria in Vienna. I'll travel here to Orlando. I need to do a media call. My traffic, if I need to use the media relay, if I need to use my media relay, will go back home to Ireland and back again. The transport relay is much smarter. The transport relay uses a dynamic discovery with any cast IPs. We'll talk about any cast IPs on the next slide. And that helps me to, based on where I'm located at the moment, find a transport relay to use. That means I travel to Orlando. I want to do a call. hey, now I can find here a transport relay somewhere in the US, and I don't need to send all the traffic back to Europe. And because we have this flexibility that we can discover based on the location of the user which transport relay to use, this is why it's so important that when you design your network, that all your offices have local internet breakouts. Because if I collect all my traffic and send it first to a central point, well, then I don't get any benefits of using these distributed transport relays. And I understand it's easy for me to say here that you should just redesign your network, and it might take a lot of extra effort, but it makes really sense. And if you ever get into a position where you need to argue why local internet breakout might be useful, that is one of the reasons. There were 2 sessions already at Ignite. Both of them, the recordings are available. One is learn about Microsoft Global Network and best practices for optimizing Office 365 connectivity. It's all up about all Office 365 workloads, why you should have local internet breakouts. And then there was one specific, demystifying internet connectivity to Skype for Business Online and Microsoft Teams. So I highly recommend watching these sessions. The media relay uses UDP, the same UDP port for all the workloads. That means if you look at the UDP streams, you couldn't tell if this traffic is audio or video or desktop sharing, which makes it hard for you to apply any prioritization of traffic. With the transport relay, we can use different UDP ports per workload. Today, Skype for Business Online still uses the media relay sometimes it uses the transport relay. We are currently in rollout, and it's what we call a quality-based rollout. So we enable a few tenants, we see it works well, we enable more tenants, and then more and more and more. And actually, it's not binary if a tenant is enabled, but we enable maybe 1% of the users to use the transport relay. And by just chance, whenever you sign in, you might be the 1% today who gets the transport relay, or you might get a media relay. And then a few weeks later, it might be 5%, and if everything goes well, it's maybe already 100%. So you might be running transport relay already and just not knowing it. Teams is always using the transport relay. So we didn't backport any of that media relay to Teams or port that because when we built Teams, we said, well, let's start with all the new good stuff. A little bit more background on the transport relay. The transport relay uses this Anycast IP address. That means there's one IP address that's assigned to all these servers that are all over the world. And there's IP routing that ensures that always the closest instance is used. Well, it's obviously, this is not geographically, not necessarily the closest one, but in terms of routing. The least hops that you need, that's where you will be routed to. And this is based on the actual endpoint location and based on privacy boundaries. For example, if you are a client in the US government cloud, where we haven't rolled out transport relay yet, I believe, but we'll have soon. But if you're using the US government cloud, then you will always use transport relays that are in the US, even if you travel to Europe, because, well, you're paying for that all your data is in the US. If you have your tenant in Europe, you will always use either European or American relays. And other tenants, they can use transport relays worldwide. They don't have any restrictions. The transport relay itself, all the traffic that it will be seeing is encrypted. It doesn't know the key. So even if it would be, well, even if someone would be able to look at the traffic, they would need a lot of extra effort to find out the keys to decrypt the traffic. But still, we want to be conscious about the choice that you made, where you deploy your tenants and what it means on what services you use where. In terms of discovery and load distribution, we already talked about the Anycast IP, that is one IP that then brings me to the most local transport relay. And then on the transport relay, we use a load balancing mechanism, and that's now really just a little view behind the curtain, because you're probably not ever going to see any of these, but helping to understand some of the benefits of the transport relay. So behind the curtain, we're using equal cost multipath routing. It's basically a hash based on the source IP, destination IP, and a few other things. And that's how we can very quickly, very easily distribute the load to different transport relays that are behind this one IP address. And the nice thing is that it's not complicated for us to change that setup. If we need to shut down a transport relay, it just removes itself from this algorithm, and there will be no downtime, and then we can add it again. So it's super easy for us to manage, and that will positively affect the SLAs that we can deliver. So let's look at all of this now in action. ICE consists of 5 phases. During the sign-in, my client will get credentials. And depending if I'm using Skype for Business or Teams, depending if I'm already on the transport relay or not, I will get these credentials from the Media Relay Authentication Service, the MRAS, or the Transport Relay Authentication Provider, the TRAP. That happens once when I sign in. And then, every time when I establish a call, we will do a candidate discovery. That means I want to call someone, so I press the call button in my client, but before I actually send any traffic, I want to know where I can be reached, so I need to discover these candidates. Once I know where I can be reached, potentially, I send these candidates to the person I want to call. They send back their candidates. That's the candidate exchange. And then we're going to do connectivity checks. So now I know where this person could be potentially reached. They know where I could be reached. We try to establish a connection. And if we can establish connection, and we should be able to, then there will be the candidate promotion, where we then select the best media path, and then we will use this best media path to conduct our media session. A little double click on the relay credentials. So these are the credentials that I need to have so that I can use the media relay or the transport relay. The media relay or the transport relay, it doesn't know my identity, so I never authenticate against these components. However, I authenticate against the service when I sign in via the signaling. So the way it works is I sign in into the service. From the signaling, I learn that there is a relay configured for me. So via the signaling, I send them back to the service a request and say, hey, I really would like to use that relay. Can you get me credentials and more information? And now over this trusted signaling path, the service knows that it can trust me, and the service will now reach out to either the TRAP or the MRAS and will say, well, hey, you might not know this user, but I know the user. So trust me, you can give me the credentials, the username and password, give that to me, this token, and I'll pass it on to the user. And then the client receives these credentials via signaling. And now the client has the credentials, and every time the client wants to do a call, it can go to the media relay or to the transport relay and can say, hey, look, I have these credentials. The relay will say, I have no idea who you are, but someone I trusted gave you these credentials, so please come in and consume my services. As you have realized, there are a lot of subtle differences. So you can have Skype for Business with Media Relay, Skype for Business with Transport Relay, or you have Teams. And I really want to point them out here just for the understanding of the development that we are doing in the background and how we're improving these services. So the option 1 is that you have either Skype for Business online using a Media Relay, or you're using Link 2010. So even if you are in a Transport Relay already, if you're using Link 2010, you will always use the Media Relay because we didn't integrate all this intelligence there. But that basically means the MRAS on the assigned relay will create my credentials. So the example is, again, I'm homed in Europe. I go then, my assigned media relay is the one in Dublin. So I go to the Dublin one, or well, the service on my behalf goes to Dublin one and create these credentials for me. The option 2 is that I have Skype for Business online with Transport Relay, and I have Link 2013 or newer. And in that case, the client will still use the MRAS, and the MRAS will then, on behalf of the client, go to the TRAP, to the Transport Relay Authentication Provider, request credentials, and will give that to me. To my client, this will be fully transparent. My client wouldn't know that that in the background the MRAS is talking to a TRAP. But with the TRAP, we can use all these servers worldwide. And then finally, option 3, Teams. Teams doesn't know about the MRAS anymore. It only uses the TRAP. So when the Teams client signs in, the service will go directly to the TRAP and provide these credentials. So we're going to do a first demo now and going to look at these credentials. And I turned off my PC. That's fantastic. OK. So what I've opened here is Snooper. I'll have the link later, and it's a tool that makes it really easy for me to read Skype for Business traffic, the zip logs. So this is a zip log, and I could open the zip log just in a text editor and have a lot of text, and it would be super confusing. But with Snooper, I can see here all the different zip dialogues that I have. So I can see here there's out, there's registration, there's unauthorized. And on the left, I can see always the zip message, header basically, a summary, and then on the right, I can see the details. What we are going to look for is the MRAS, the Media Relay Authentication Service. And if everything is working fine, and it should be, then you will find always 3 results. The first one, let's take a look at that. The first one is an incoming 200 OK, and that's what we call the in-band provisioning. This is where my client learns how it is configured. So I can zoom in here now, and for example, I learned here what the minimum and the maximum audio ports are that the client is supposed to use. So that's how we provide a lot of information to the client, how the client should behave. So we can see here all of this detail, but what we are interested in is really this MRAS information, and I can see here that there is an MRAS URI configured, and that basically means, yes, for this user, there is a relay configured. Office 365, you don't have any control over that, so you should always see that. If that's not there, then we have a big problem in our service. So this should always be there. Anyway, the next one is then the service request, where now my client knows, oh yeah, there's a relay configured for my user, so let's get credentials for that. So we send a service request to the server, and we send here information. That's the service request. Whoops, and that's my identity. So obviously I'm not Martin, but I created that log with Martin. And there's the duration. So I'm going to request credentials. I want to have them valid for 480 minutes, so that's 8 hours. So Skype for Business credentials are valid for 8 hours. For Teams, it's 24 hours. However, you don't really need to care about that. Once they expire, the client will just get new credentials. And then, and that's now the more interesting part, we see here another 200 OK coming in. It's the credential response. And I'm going to look here at the credentials and expanding the media relay list. And I can see here a username and a password. Whoops, that was not intended. I can see here username, password, and duration. So the MRAS used this certificate to create a username, to create a password, and if I ever want to use the relay, then I will present the username and password, well, hashes, and there are some additional security factors, but then it will be able to, because it used its own certificate to create these credentials, it will be able to verify and say, yeah, this is something that I created, so you are trusted. And the 8 hours are there. But what's more interesting, or also very interesting, is down here, the media relay list. I can see here that there is a location. Where is my user located? Well, all of our users are in the internet, because if you have an on-prem server, you would sometimes see internal here or intranet, but in Office 365, every user is external to Office 365. I learn a host name, and here it is trh.online.link.com, and I learn the ports, how I can talk to this media relay. So now I know where the media relay is, what the ports are, and what my username and password is. And because I know what it should look like, I know now that this user is using a transport relay. Whenever you see trh.onlinelink.com or trh.us or trh.eu, this means this user is going to use a transport relay. There's a second indicator how you can see that this is a transport relay. There's only one media relay in the media relay list. If this would be a media relay, then you would actually see 2, one for the internal and one for the external. However, in Office 365, I just said there are no internal users. So this was just part of the, we take on-prem stuff and put it in the cloud, and now it still behaves like on-prem stuff. So now my client knows how to connect there, and that's the Skype for Business client. If I want to see the same for Teams, then I need to get a little bit tricky. So for Teams, we don't have any nice to read customer-facing logs. However, as I said before, all this traffic is HTTPS and sometimes WebSocket. So you can use tools like Snooper, or I'm using here Charles Web Proxy, that basically creates a proxy on your machine. You need to trust the certificate, and then does a man-in-the-middle attack, where all the HTTPS traffic goes through this proxy, and now you can read it. The nice thing about Charles is that you have here this traditional sequence view, where you can see what message follows what message, but then you have also this structure view, where it shows you which component you were actually, or which URL you were actually talking to. What I want to look at now is I want to search for MDN_trap, and then you should find, hopefully, this configuration teamsmicrosoft.com, and then there's an MDN trap. Looks still very confusing. I switch here to the JSON view. That looks a little bit nicer. I can here expand the MDN trap, go here into the relay, can see here the address and the port. Interesting here to notice is the address is not an FQDN, it's an IP address. So in Skype for Business, for backward compatibility, because we wanted to make all of that transparent to the client, we provide an FQDN because this is how we used to do it in the part with the media relay. In Teams, we don't have that luggage. We don't need to introduce potentially any complexity with having an FQDN. We just tell them the IP address directly, this Anycast IP address. Okay, so MRAS, or actually that should say credentials. Same, but different. So if I have Skype for Business with Media Relay, you will learn the FQDN of a specific media relay pool that's in one location. If I have Skype for Business with Transport Relay, I learn the FQDN that points to that transport, well, I learn an FQDN, and this FQDN points to the Anycast IP of the relay, of the transport relay. And if I have Teams, I directly learn the Anycast IP. Okay, so now my client knows how can I talk to my relay? And that's the step one. Now I want to conduct a call. So I said every time I'm doing a call, I need to first discover my addresses. I need to know where I can be reached before I tell the other person that I'm going to call them, so that they then do the same and can let me know where I can reach them. So on the very left, you can see here the endpoint. In this case, we have one network card. There's some net or firewall, and then there's our relay. The first candidate that we will always discover is the local one of my local IP address. If I have multiple network interfaces, I will discover multiple local IP addresses because whoever I'm talking to might be able to talk to one of those. Then I will send this allocate message to the relay and will ask the relay and say, hey, dear relay, I want to do a call. Please allocate a candidate for me. And the relay will then give me a candidate and say, well, if you need to use me as a relay, here's candidate C in the picture. That's the IP address, my public IP address, and the port. So whoever you're trying to talk to, they can talk to that port. And at the same time, I can see that when you send me a message, that's actually coming from this IP address, from the reflexive IP address that we have here as B, or the reflexive candidate. So the relay lets me know that all my outgoing traffic, what the IP address of that outcoming traffic is. Then I do the same for TCP. We prefer UDP, but if we can't do UDP, well, better we can do DCP than having no call at all. Allocation, same but different. If I have Skype for Business with Media Relay, then the client will always connect during the allocation to the media relay on port 3478 UDP and 443 TCP, and will keep using these ports. If Skype for Business is used with the transport relay, it will also connect to the Anycast IP via port 3478 UDP and 443 TCP, but then this transport relay will tell me two things. First, here's a new IP. Don't talk to the Anycast IP, talk to this specific server that you're going to use for this call. So it will redirect me to a different IP, and then it will also give me a different port based on my workload. So if this is an audio call, it will tell me, hey, that's audio. You should talk to 3479, or it's video, 3480, or it's desktop sharing, 3481. If it's Teams, similar, but not the same, It connects via Anycast IP to the Anycast IP on 3478 UDP and 443 TCP. It will be directed to a SPICX server, but at this point of time, we are not redirecting to another port. We plan to enable that in the near future, and that will help you to prioritize your traffic accordingly. But whenever I, as an endpoint, talk to my own transport relay, as a Teams endpoint, talk to my own transport relay, this traffic on UDP will be 3478, no matter the workload. And I didn't include here TCP because TCP will always be 443. There is no redirection or no specific ports. And what is here 4478 should be 3478. My apologies. Candidates. Also, how we allocate the candidates is a little bit different. In Skype for Business, there are scenarios that work only with TCP. So if you're doing the file transfer, the one-to-one file transfer where I send someone a file, it will be only TCP. We won't be doing UDP for that. And also, if you share your desktop in certain scenarios, we will use RDP, the remote desktop protocol, and that also requires TCP. The scenarios are, you do application sharing and not screen sharing, or you give someone else the control over your sharing, or you're doing a sharing session with someone who doesn't understand the other way, which is called video-based screen sharing. So in these cases, we have to use TCP for Skype for Business. Also, what's interesting, the allocated ports, they will always be in the 50K range. So every time the relay tells me, hey, you can use this port will be in the 50K port range. Teams. In Teams, all workloads support UDP, and also in the Teams candidate list, you will see only UDP candidates. We will tell whoever we want to talk to, you can talk to these UDP candidates. If they can't do UDP, for whatever reason, they will have to talk to TCP to their own relay, and then we can talk to that relay. But we are not announcing or telling people any TCP candidates there anymore. And now, specific on the workload, we will allocate a different candidate. So if I'm now doing an audio call and I tell the relay, please give me a candidate so that whoever wants to talk to me can talk to you over the relay, then depending on the workload, it will be a different port. So audio will be 3479, video will be 3480, and desktop sharing 3481. Okay, now I did the discovery, so I'm here, the endpoint on the left side. I know where I can be reached. So via the signaling, I now send this message to the peer I want to talk to. Could be service, could be a user, and say, hey, you can call me here. Then the other endpoint will do the same, will discover where they can be reached, will send everything back to me. Now we both know where we can be reached. The other person hasn't picked up yet. So I could be calling someone, they don't pick up the phone, but we have already exchanged the candidates. We are already establishing a media session. Why? Because we want to get sure that as soon as the person picks up, media session is established, and when they say hello, that they can hear that hello. Then eventually the person picks up, hopefully, they will send an OK message, and then again the candidates, and then we know, okay, this is the endpoint we are talking to. So let's take a look at these logs. So in order, I'm now back in Snooper, so we're looking at Skype for Business. In order to find them, I'm searching for A equals candidate. And we are looking here at the call where Martin called Thomas, and the first thing that I can see is the out invite. So looking at this out invite, I can see here on the right what we call the STP, the Session Description Protocol, where basically Martin tells Thomas, I want to talk to you, and this is what I'm capable of. So I can see here that this is an audio call. Just scroll down here. So I can see here, this is an audio call. I can see here all the candidates. We'll talk about them in a second. But if I scroll down, we can see here much more information. This is, for example, all the codecs that Martin supports. So we don't exchange only information about how do we do the connection, but also we agree on what codecs are we going to use. So let's look at the candidates. So the candidates is quite an impressive list. One thing that you might realize first is when I look here at the first number, the first two are 1 and 1, then I have 2 and 2, and then I have 3 and 3, and so on. Reason for that, candidates come in pairs. There's one candidate that they use for the actual real-time protocol, and there's one that they use for the real-time control protocol to send control information. So they are numbered 1 and 2, indicating if they are the one or the other. Then I can see here that this one is a UDP candidate. Then I can see here a really long number. This number is actually a priority. The higher the priority, the more I want to use this candidate. Then I can see an IP address. And this is now this IP address of this specific candidate. And I can see the port numbers. And then I can see a type. The type is host. By looking here at host, I know this is the local IP address of that endpoint. There are other interesting types that we want to look at. There's a type that's called server reflexive address. So this is the reflexive address. When I send a packet to the relay told me, hey, actually the IP address that I see this coming from is the following. I can see here to the right this IP address that matches exactly the IP address of my host address. So the relay tells me, hey, when you send me a message from the address 192.186.110, I can actually see this coming from this IP address, which is 91.205, and so on. So I learned this reflexive address. And then finally, we have here the relay address. I'll pick this one. And this is now the relay address with the IP address of this specific relay. So if I cannot establish a direct connection or a connection via the reflexive address, then maybe the person I talk to can talk to my relay. Other things that are interesting here to see is we can obviously see here that there are some IPv6 candidates, and I can see here that there are TCP passive and active candidates. If I have a TCP passive candidate, I know that this candidate will be able to receive traffic as well. How can I know that? Well, because these are the candidates of the relay, and I know that the relay will be able to receive traffic there. The relay, the active and passive, they will actually match each other. So if you compare these two lines, it's the exact same candidates. Okay. Now there's the session progress. That's actually twice here, 183 session progress. This is now coming back from the called person. It's like, yeah, you're trying to call me. Here you go, here's my information. So question is, why are there two? If I zoom in here, in the packet, in the SIP message, then I can see here that this one message is coming from Skype for Business, and this other one is also coming from Skype for Business, but actually from an Android phone. So in this case, the called user was signed in with two clients at the same time, and it could be more, it could be 4, 5, 6, and all of them ring, obviously. And with all of them, we establish a media session because we don't know where the called person is going to pick up, and we want to get sure that we have established a media session. So when they pick up, we're doing that. So at the same time, we're establishing media sessions with all of them. So looking now here on the incoming packets, now you might realize there are no pairs anymore. It's just 1, 2, 3. The reason is we built in some optimization. We figured out, well, why should we use so many ports if we can just multiplex the RTCP and the RTP over one candidate? However, when we establish the call, we don't know if the person we are calling, the client we are calling, if they're able to understand this new format. So we sent the old version, and we sent also a flag. You can find it somewhere down here. Or a parameter, this RTCP max multiplexing. So I sent the old version and say, hey, by the way, I know the new version as well. If the other peer knows the new version as well, they just send the new version back. One other thing that's very interesting to see here is about the encryption. So I can see here this crypto, and there is the cipher suit that I'm using, and then there is this encryption key. So this is how the two endpoints will actually encrypt the traffic. They will, via the secured signaling channel, they will let each other know how they are going to, which key they are, and which security cipher they are going to use to encrypt the traffic. And so now only these two endpoints know how to encrypt the traffic. That relay never sees this kind of traffic. It never sees the signaling. So the relay just sees encrypted packets and passes them on. Okay, switching back to the presentation. And that's really about the media encryption. So when we talk about the MRS credentials or the trap credentials, they are there to allow the endpoint to allocate this token so that we can talk to the relay. But they are not used to encrypt any traffic. The traffic is encrypted with real-time protocol or secure real-time protocol, and this negotiation, as we have just seen, happens during call setup. Now, next step is connectivity checks. Now both endpoints know where the other one believes they can be reached. Now they will try all kinds of connections. So they will determine all possible UDP and TCP pairings. The relay can actually bridge between IPv4 and IPv6. So if one can just talk IPv6 and the other just IPv4, the relay can make that happen. For teams, the relay can also bridge UDP and TCP. That means in Skype for Business, if I have a client that can talk only TCP to the relay and the other one can talk UDP and TCP, the whole call needs to be TCP because one can do just TCP. In Teams, if I have the same situation, one can only do TCP, the other can do UDP to TCP, the one will talk TCP to the relay, the other one can talk UDP, and then the relay will do that translation. So we find out which candidate pairs work, and then based on the prioritization that we have seen before, we select the best one, the most optimal, the most direct one, and that's the one that we're going to use for the call. Then, yeah, and all of this we cannot see in either Snooper or the traffic that we capture with Charles. However, we can see that in Netmon, for example, but it's a little bit difficult to read because there's a lot of connectivity checks going on. What we can see again is the candidate promotion. So after the other person picked up and we have identified the best candidate, we can see which candidate that is. The rules are we prefer IPv4 over IPv6, we prefer UDP over TCP, and we prefer the more direct path. We will then see in our logs a re-invite, and then there will be only one candidate in the SDP, and that will be used as the candidate that we want to use for this call. I mentioned several times that we prefer UDP over TCP. As you know, TCP is a very good protocol in terms of it protects you from losing information. If I send a packet, wherever I sent the packet, they will send me back an acknowledgement that they got the packet. If I don't get that acknowledgement, I wait, and then I resend the packet. And that takes time. And it's great if you don't want to lose any information, but in real-time communication, we want to get sure that the traffic that I'm sending gets to the other side as quickly as possible. Obviously, we don't like losing packets either, but if we lose a packet, we don't care as much. A packet probably contains about, 20 milliseconds of voice? You wouldn't even hear that. And the codecs are smart, they can recover some of that information. So if you have occasional packet loss for UDP, that's not really a problem. For TCP, that would include the lost packet, would include huge delays, and then you would run into bad call quality. So in UDP, we have this fire and forget approach, which is really ideal for real-time communication. So let's take a look at the final candidates. Before we do that, sorry, just forgot. I wanted to show these candidates in Snooper as well, what it looks like for Teams. So what I'm going here now to do is, again, the Snooper log. I search here for A equal candidate, and I'll select this specific conversation. And as you can see here, very beautiful to read. Everything is just one single line. It's super long. I can take that, maybe. Well, if you copy it in Notepad, it's still one super long line. You can see here that there is this /r/n. So this is actually a line break. So what I did is I copied all of that before the session, copied that into a different text editor tool that's a little bit more powerful than Notepad, and then I replaced this /r/n with line breaks, and then you will end up with something like that. Still not super nice to read, but you might already recognize, hey, the candidates are back. And then if I scroll down, I can see here also all this information around codecs, so I can basically the same information of the SDP is also here. Then I can scroll down and then I see all kinds of stuff that's difficult for me to understand, so I'll stay here at the top. And it looks very, very similar. But one thing that I mentioned before is that based on that these relay candidates, here's the relay candidate, that it will use ports based on the workload. So I can see here that it uses here 348. Not a high port, it's really based on these few ports. The other interesting thing that I can see here, well, at least I think it's interesting, that all relay candidates will come with this mturn ID. And the reason for that is, it's about security on who can access my service. In Skype for Business, we always use this huge 50K port range, 50,000 to 50,999. And when someone wanted to allocate a candidate, we randomly picked one of those, and that gave us some security because this port was really open for a very short time, and you needed to guess the right port. And then when you connect, you still needed to have username and password and these things, but it was an additional layer of security. Now, if we use the same port for all connections, well, now everyone can just go there. Well, they can't, because they need to have this mturn ID, and only if they present the mturn ID, they will be able to connect to that port. So anyway, let's look at Snooper again, and now we want to see the final candidates. I'm searching here for A equals remote candidate. I get 2 results. I scroll down here in the first one, and I can see here the candidate list includes only one candidate. It's a peer-reflexive candidate. So a peer-reflexive candidate means it's a reflexive candidate, so whoever I'm talking to, they talk to my net device, and it's peer-reflexive because this specific port was discovered during the negotiation. The IP is the same as the server-reflexive, but the port is a different one. And that's just based on how net devices work. So in this case, the net device was configured that if I talk to one IP address and then to another, it would use a different port going out, and we discovered this one. If I look here now on the 200 OK, I can scroll down here as well. I can see here the remote candidate. Sorry, I confused myself. Here, it's the relay candidate. So this client is actually talking to the relay. So what we have here is that we are talking to from the calling person to the relay of the called person, and there's one relay in the media path. And now I understand how this traffic is flowing. Okay, call flows. So I mentioned that before. In Skype for Business or Teams, when we have a one-to-one call, we want to send it as directly as possible. Different if it's a meeting. If it's a meeting, we would send it to the cloud anyway, because the cloud needs to mix all the audio, needs to collect all the video and send it out. But this is now specific to a one-to-one call in Skype for Business. And what you can see here is that I have these 2 Skype for Business clients. They have their own relay. Here I have port 443 and the port 3478 to 81, 443, 3478 to 81. So the first thing that's going to happen is that they both connect to the relay, allocate candidates. We have discussed before, the Skype for Business client will go to port 443 TCP or 3478. UDP, for UDP it will be then redirected based on the workload, if it's audio 3479, and so on. So both endpoints do that. Then they try to establish a direct call, because that's the best option. At the same time, they try to talk via the relay, and now the calling client tries to connect to the called client's relay on the 50K port range, because that's the candidate that it allocated for me. At the same time, we are trying to do the same with the other relay, and if all of them work, fantastic, then we'll pick the direct one. If the direct doesn't work, well, then we'll take the relay of the called client. If that doesn't work, then we take the relay of the calling client. And if both of them don't work, then the relays need to talk to each other. And I will talk to my relay, the other one will talk to his relay, and then the relays talk to each other. And this is why it's still useful if you have Skype for Business, if you keep the 50K port range open. If you have the 50K port range open, I can establish calls where I have only one relay. If I close the 50K port range, which we recently said is not required anymore, you have two relays in the media path. We have looked in our telemetry what the difference is in quality, and it turned out the difference is not very big. It's very small, calls might be setup might be a little bit quicker, so we don't think that it's worth going through the effort if you don't have them open to have long discussions with the security team to get them open. However, if it's really easy to get them open, or if you already have them open, there's no reason to close them. You will get still benefits out of that. Teams. So similar concept, the Teams client, they connect to their relay on 443 TCP or 3478 UDP. So they, to their own relay, they always talk only 3478. Then they will test the direct one. They will try to talk to the other one on 3479 to 3481, depending on the workload. The other relay will also be tested in Teams. And if all of that doesn't work, they could still talk to each other. So, what happens if a Skype for Business client now talks to the service, to a mediation server, to a conferencing server? So the server, I put it on the right side to indicate that's internally to the network, but the principle is the same. Client talks to its own relay, 443 TCP, 3478 to 81 on UDP. The server does the same. Now, the client will try to talk directly to the server. And if you haven't firewalled it, it might be possible. On the high port, it's not always possible. It depends a little bit where the servers are located. So we wouldn't guarantee that it works, but don't be surprised if you see that. If it doesn't work, then we would use the relay of the called endpoint. That would be the one of the server. And if that doesn't work, then the relay would talk, the server would talk to the relay of the calling of the end user. You should, in this scenario, never see two relays, because we expect that the service can always talk to the 50K port ranges of our environment. Well, we control that, so we open these ports, so hopefully that works. In Teams, well, the Teams client will allocate candidates. The service will never allocate candidates, because we know that the service can talk to the relays. It doesn't need its own relay. Again, we are trying to have the direct connection. If the direct connection works, perfect. If it doesn't work, then the Teams client will just talk to the assigned transport relay, and the service component will talk to the exact same instance of the relay, the exact same relay. So, bringing all of that together in a single table, the ports that we're using. Here on the very left, we can see the workloads that we are talking about. So are we talking just about allocating candidates, audio, video, or desktop sharing? Then we can see here the Skype for Business client port, the Teams client port. What happens if you have a media relay? What's the service port there? Or what's the service port if you have a transport relay? So let's start with the Skype for Business client port. While I allocate my candidates, I will honor the client ports that Skype for Business is using per workload. So that's 50,000, 50,019 for audio, 50,020 to 50,039 for video, and 50,040 to 49 for desktop sharing. And all of this will go, if I have a media relay, it will go to 443 TCP, 3478 UDP, or if I have a transport relay, it will also go to these ports, and then, as we have learned, it will be redirected. So once Skype for Business has established an audio call, it will go, if it's a media relay, still to 443 TCP or for 3478 UDP. But if it's a transport relay, it will only go to 3479 UDP or TCP if we need to use that, but we don't want to. For Teams, it's at the moment a little bit different. Teams client as a source port will always use the whole high port range, 1024 and up. We plan to change that. We plan to have a similar implementation like Skype for Business so that you can actually look at the traffic and say, oh, that's 50,018, so I know that must be audio. Not today, but soon. When the Teams client talks to the transport relay, then When it talks to its own transport relay, as discussed, it will be UDP 3478 always. We plan to change that as well. So eventually, you will be able to look at the team stream and say, oh, this is going from this source port, so I know that it's audio, to this destination port, so I know that it's audio. At the moment, we're still working on that. Here, a couple of do's and don'ts when it comes to media. Direct connectivity is required. Every one of your clients needs to be able to connect directly to Office 365 so that they can establish that media path. They need to be able to talk directly to that transport relay or media relay. Don't put any proxies in there. Don't shape the traffic. Don't do deep packet inspection. Everything very bad and might make the user experience worse or just prevent calls in the first place. If possible, use local internet breakouts so that we can go to the next transport relay on the shortest route as possible and then route the traffic over the Microsoft network. We will prefer UDP over TCP because it's just better for real-time media. TCP can be used as a backup. In Skype for Business, it's used for some of the scenarios, but if possible, we want to use UDP. It's also important that you look at the documented list of IPs and FQDNs that you need to open your environment to. There is a list. I have this short URL, AKMS 0365 endpoints, and it's quite a list of IP addresses and FQDNs, and obviously we like to change them a lot. So get sure that you look at them on a regular basis. Even better, subscribe to the RSS feed so that you learn every time we update that. Because if you have configured your environment to open it to only very specific IPs or FQDNs, then you need to get sure that it's always up to date. Otherwise, you might have connectivity issues. And again, open the UDP ports. And there's something that might be very important for customers who are using Skype for Business already for a longer time, who have it implemented, who a year ago followed, or maybe 1.5 years ago, followed the recommendation that we had then, and the recommendation was for media, open 443, that hasn't changed, but open also 3478, that hasn't changed either. What has changed is that in the past, we didn't require the 3479, 80, and 81. So we know that there are lots of customers out there who haven't opened these additional UDP ports. And the problems that they are seeing is that with Media Relay, everything worked fine because they had all the required ports open. But now they're getting enabled for Transport Relay. Now their clients try to connect to the Transport Relay on 3478. Works fantastic. They want to allocate candidates, but then the Transport Relay says, well, you need to talk to this IP address. Still not a problem, but you need to talk to this IP address on this port, which is 3479 or 80 or 81. But if the customer didn't update the firewall rules, and if they don't allow these, then UDP connection will fail. They won't be able to have a UDP call anymore, and now the media will go over TCP. So no one will call the help desk and say, hey, I wasn't able to do the call because the call will still succeed, but the quality might be just much worse. And that's something that you need to look out, so get sure that all of the UDP ports are open. Just one word about Skype for Business Hybrid. If you have Skype for Business on-premise and Skype for Business online, basically you need to bring together all of the requirements. So all the endpoints should be able to talk to Office 365. The Edge server that you have on-prem needs to talk to the cloud as well. They don't need to have these new ports, these 3479, 3481 ports. They are really just for client to service communication. The Edge server will not do it. Edge server will still talk 3478. Okay, so now hopefully we understand in every detail how all of this works. Now a few tips on troubleshooting. Capturing logs, Skype for Business, super easy. There's a log, it's called UCC API log. You can open that in Snooper. That was the tool that I showed you. Snooper is part of the Skype for Business Server 2015 debugging tool, so you can just download that, read your logs, and be very happy about that. Teams, not so easy. So you need to do this trick with installing the local proxy, doing your own man-in-the-middle attack, collecting this traffic. Examples for tools are Fiddler or Charles Web debugging proxy that I used. Where do I find the logs? In Skype for Business, get sure that the logs are turned on, otherwise you don't find them. Then go to, I'm not going to read that, go to these locations to find all of the logs. One thing that you also might want to do is, if you want to see the MRAS or trap provisioning, you want to get sure that you close the application, delete the logs, start the client again, so that you can see the full sign-in process. So in general, if you want to reproduce any problems, I would always get sure that you start with a clean log. Some search tips for Snooper. So search for MRAS, then you find the in-band provisioning, the MRAS requests the MRAS provisioning. If you search for A equals candidate, you can find the candidate exchange. And then if you search for A equals remote candidate, you find the promoted candidates that were used for the specific call. One additional tip here is if you're reproducing any problem and you want to get sure to see the A equal remote candidates, sometimes after the other person is picked up, that can take about 6, 7, 8, maybe 10 seconds. So what I always do is I get sure that if I reproduce a problem, other person picks up, that I let the call running for 20 seconds and then disconnect the call so that I can get sure that these final candidates are there. Reason for that is that when the other person picks up, we might not do the call at this point of time over the optimal candidates. So it is possible that if someone picks up very quickly, that we're still in the background checking for a better connection, and we are actually switching to a better connection, to a more direct one. However, once you see the remote candidates, this final candidate pair, there will be no more candidate switching. That will be the one. So if at that point of time some firewall changes somewhere, well, then the call will drop. But usually that shouldn't happen too often. In Teams, I used Charles. It's a little bit, here's a guide on how to configure that. The most important thing here is your mileage will vary when you do the logging. So these WebSocket connections, they can be very persistent, and in my tests, I had a very hard time to capture them every time. So sometimes I would close Teams, I would wait for 10 minutes, I would start the logging, I would start Teams, and sometimes I would see it, and sometimes I wouldn't. Sometimes I would just see this decrypted. Unfortunately, I'm not too much an expert in WebSocket and this technology, so I didn't find out the best way to do that. Just be aware that sometimes you might see what you want to see, and sometimes you won't. In addition, what I've showed you today is how Teams does it today, and that might change. We are very dynamic. We do a lot of updates. If we see a potential for improvement, we might just do it. So it could be that when you watch the recording at some time, or when you test it in a month, that it looks completely different, and well, that can just happen. So this is more a point of time snapshot. If you want to see this trap information, search for MDM_trap to find the relay information, and then A equals candidate and remote candidate for the candidates. One thing that can be very useful in troubleshooting is the call quality dashboard. After every call, every Skype for Business client, every Teams client sends over the signaling a huge packet back and says, hey, this was the call quality experience, and this were the IP addresses, these were the codecs that we used, and we used UDP or TCP, we used an edge server or not, all kinds of information that can help you to find out in your environment how the call quality is. And you can look there into the data and create some filters. And for the purpose of that session, what you can look at is you can really look at how many UDP calls and how many TCP calls did I have, because you shouldn't see a lot of TCP calls, or maybe any. There is the practical guidance, My Advisor, we launched it this week. It's based on the Skype operations framework. You can go there, and then you can get much more information on how to use CQD. I'm sure you can fill a couple of hours with training on that. I just want to show you what is interesting in the context of that session. There was also a session on call quality management for Skype for Business and Microsoft Teams earlier this week, so you might want to catch the recording for that. So this here is now the call quality dashboard, and I'm creating here, I created here a filter. This is just screenshots because I wanted to get sure that I can do this without network connectivity. What I did here is I collected dimensions, the media type, and the transport. That's why, for the purpose of this example, I was interested in. So I wanted to know what is the media? Is that audio, video, or desktop sharing? Then the measurement is just the total stream count, and then I wanted to see the transport if it's UDP or TCP. And this is then the report that I created. And you can see here on the very left, that's a really high bar. And if you can't read it, this says TCP here. And I shouldn't have so many TCP calls, or should I? There are no UDP calls. Reason is, down here, it says app sharing. And app sharing translates to remote desktop protocol. It is TCP only by design. So I shouldn't be surprised that I see that higher on TCP than UDP. Teams doesn't have that, so obviously this customer, this environment is either using Teams and Skype for Business or only Skype for Business, but there is still Skype for Business. What I would want to investigate is probably why do they have so many TCP sessions? Because if I go over here, you can see here VBSS, video-based screen sharing, and there are very few sessions in total. So for whatever reason, this customer has really a lot of RDP traffic going on. That could be they're doing only application sharing, not desktop sharing, it needs to use RDP. That could be that they share, that they give control all the time, or it could be that they have really old clients. So if I see this report, what I would do is I would investigate, and you can also do that in CQD, investigate what client types they have, and verify that that's not the reason why they're using the remote desktop protocol, because it doesn't give you as good experience. But really interesting here is that I have audio and video, and I can see here it's almost equally TCP, UDP, so it's definitely something I want to look at why there are so many TCP calls. So let's create another report, and now I'm doing the dimensions transport and second subnet. I'm doing second subnet because if I do first subnet, it could be the client or the server or service. If I'm doing second subnet, I always know this will be the one of the client. As measurement, I want to have the total screen count, and then I can filter for second building name and transport UDP and TCP. And if I look at that now, and please note I replaced all these subnets because I didn't want to disclose any customer data, I filtered here by the second subnet. I sorted here by the second subnet. So there's one subnet that gives me only TCP streams. So that's interesting. What I would do now is I would look at, well, is this a subnet that I even own? Or is it maybe a subnet that's users from home? So maybe I don't have control over that. Then I would look at the next one and see here, oh, subnet 2 and subnet 2, they have UDP and TCP streams. I can see here the numbers. Well, that's also a lot of TCP calls. And now I can use this, identify my top offending subnets, and then can go to these network sites and check out, well, what's happening here? Why is there so much TCP traffic? So how do I test now on a site if the ports are open or not? There is a network tool. The Skype for Business network assessment tool. Primary purpose is to test network quality. So it actually conducts a call, it will send real media to a transport relay, and then it will collect information, what's the latency, what's the jitter, what's the packet loss, and this information I can use to understand what the quality of the users will be. However, soon we are going to release a new version. We tried before Ignite, we didn't manage that, hopefully very soon. It will be able to test connectivity, and it will test if it can connect to the UDP and TCP ports. That means I can go to a PC, I can run the tool, and then I will see this specific PC where it's located at the moment, can it connect to the required ports. The way that looks like, oh well, there's also a session, it's called Real-Time Communications with Networking Planner, and maybe Cornel, who is delivering the session tomorrow, might be talking about the tool he wasn't 100% sure yet if he's going to do. So I can do test the ports, and I just run in the command line the network assessment tool. I say connectivity check, verbose, so that I get all this information, and then I zoomed in here a little bit. I can see here, for example, relay 52.114.60.1 is reachable using protocol TCP on port 443. And then it tests 3481, 3479. It tests all the ports against the set of IP addresses. These IP addresses, they are downloaded at runtime so that we have always the up-to-date IP addresses. So if you're seeing any connectivity issues, or if you are not sure if the ports are open, the tool is a fantastic way to just go to a client and say, well, to a PC and say, hey, can I test that? You run the tool and you see if connectivity is working. There might be still situations where connectivity is working, but something in a way decides to corrupt packets, then you will still not have a UDP call if you have corrupted packets, but the tool might work. So if that shows everything is working, but you still don't think that everything is, then it might make sense to do also netmon and trace a call and see what's going on behind the scenes. So, resources and summary. These are all the links. I'll give you a moment to take your pictures. Basically, everything we talked about can be found here. There's also a session that I'm referring to. It's called Troubleshoot Media Flows in Skype for Business across online, server, and hybrid. It's a very, very similar session, but it includes on-prem. It doesn't include Teams. And then you can find here all the other great things that we talked about. The related sessions, I referred to them during the session. There's only one coming up anymore. It's the real-time communications with Network Planner. All the other sessions, you might want to catch the recording. So now, hopefully, we understand the challenges for media connectivity, what makes it difficult. We understand how we find the most optimal media path, and we know with these tools how I can identify connectivity issues. The traffic can be between peer-to-peer, between clients directly, and from the client to the server. And that's important when you design your network and plan for the traffic. It's important that you leverage local internet breakout if you can. And very, very important, get sure that all the ports are open, 3478, 480, 81, 79, well, just all of them. And well, also, please fill out your evaluation and let me know if you liked the session. And with that, I would like to thank you very much. So if you have any questions, the time is already over and I want to give the next speakers the desk, but I will hang out here for a bit, so please come and ask. I will also be on the booth. Well, after I'm allowed to leave here, I'll go to the booth and I will be there till 4 o'clock.